done some podcasts, Dr. Craig, on Tim Maudlin, a terrific philosopher, philosophy of New York University. And this article is Why Physics Needs Philosophy. This kind of goes against the grain of what a lot of physicists and people who embrace, well, scientism, to be quite honestly, against the grain of what they've been saying is that you don't need philosophy anymore. And he starts out with this famous quote from Stephen Hawking and Leonard Mlodinow. How can we understand the world in which we find ourselves? How does the universe behave? What is the nature of reality? Traditionally, these are questions for philosophy, but philosophy is dead. Philosophy has not kept up with modern developments in science, particularly physics. Scientists have become the bearers of the torch of discovery in our quest for knowledge. Famous quote there. We've done podcasts on that whole thing, decrying philosophy. Tim Maudlin seems to be saying that's not the case.
Right. Maudlin points out that physics actually needs philosophy, and he contrasts the attitude of those scientists who would say to the philosophers, just shut up and calculate, give me some results, and those who strive for conceptual clarity. And he says that what philosophy can bring to physics is tools to help come to conceptual clarity about key concepts that are operative in physics.
That quote, by the way, was from The Grand Design, their book, which came out in 2012. Maudlin says, many questions about the nature of reality cannot be properly pursued without contemporary physics. Inquiry into the fundamental structure of space, time, and matter must take account of the theory of relativity and quantum theory. Philosophers accept this. In fact, several leading philosophers of physics hold doctorates in physics, yet they chose to affiliate with philosophy departments rather than physics departments because so many physicists strongly discourage questions about the nature of reality. In other words, just shut up and calculate. It's all numbers, and so on. But putting computation ahead of conceptual clarity can lead to confusion. There are 3 C's there. That's easy to remember. Putting computation ahead of conceptual clarity can lead to confusion. Now, he gives an example here, the twin paradox.
Right. This plays a role in the recent film Interstellar, where the man goes off on a space journey and ages less slowly than his daughter at home. And as a result, when he returns, she's dying as an old woman, and he's still relatively young and looks like he did when he left. And Maudlin says that while everyone agrees that the traveling twin will age less than the twin that stays at home, it's not always clear why this is the case. And he points out that even Richard Feynman in one of his lectures got this wrong, attributing the differential aging to the acceleration of the traveling twin. And in fact, you can formulate the twin paradox simply in terms of uniform motion without taking acceleration into account at all. And so that cannot be the right explanation for the difference in aging. And so Maudlin points out here, you can get your calculations right, calculate correctly the difference in age, and yet the explanation could be wrong. And it's here that conceptual clarity can be of help.
And he points out that we're about to see this experiment take place. Astronaut twins Scott and Mark Kelly are about to realize this experiment. When Scott returns from a year in orbit in 2016, he will be about 28 microseconds younger than Mark. 28 microseconds, yeah. Wow. Who is going to be staying on Earth? No competent physicist would make an error in computing the magnitude of this effect. So, is that right? How in the world will we calculate that, Bill? That's just 28 microseconds? They got it down to
I don't know how they measure that, probably using atomic clocks. This experiment was actually done with ordinary jetliners flying clocks around the Earth in opposite directions. And they were able to show that the clocks were not synchronized when they came back. And although some of this is due to the gravitational field of the Earth, some of it was due to this effect predicted by the special theory of relativity.
It says the calculation can be right, but the accompanying explanation can be wrong, which starts getting into the area of philosophy. He continues, if your goal is only to calculate, this might be sufficient, but understanding existing theories and formulating new ones requires more. Einstein arrived at the theory of relativity by reflecting on conceptual problems rather than on empirical ones. How about that? Now, people would think if there was ever a numbers guy who just crunched numbers, it'd be Einstein.
Well, this is an example that I think goes even deeper than Maudlin lets on, because at the root of Einstein's special theory of relativity, which he enunciated in 1905, lay a verificationist epistemology that has now been overtaken by developments in epistemology and is utterly obsolete and untenable. And yet the theory erected on its foundations continues on as though nothing had changed. Einstein's critique of the notions of absolute simultaneity and absolute length were based upon the fact that you could not tell in a round trip journey of light whether or not the light went out at one speed and came back at another speed. All we could measure is the round trip velocity of light, but we couldn't measure the one-way velocity of light. And so he just assumed that the time that it takes the light beam to go from A to B is the same as it is to go from B back to A again. Now that sounds commonsensical and unproblematic until you reflect on the fact, suppose A and B are only at relative rest, but they're both moving in tandem, like a tandem bicycle, where the two riders on the bicycle are stationary with respect to each other, but they're both moving along on the bicycle as it goes down the path. In that case, a light signal sent from the back seat to the front seat will take longer to get to the front seat than it will when it goes from the front seat to the back seat, right? Because when you send the message from the back, the front is moving away from it. When it's sent back from the front to the rear seat is approaching the signal. And so the time that it will take light to travel from A to B will actually be greater than from B to A. And Einstein eliminates this possibility only by assuming that there is no such thing as absolute space, that everything is relative. And therefore all that counts is relative motion or rest. And that is an assumption that's based upon his verificationism. Since we can't measure absolute motion or absolute distance or time, therefore they don't exist. And that's, as I say, verificationist and now completely outmoded in philosophy of science and in epistemology. So Maudlin's point is even more powerful than what he lets on here. At the root of Einstein's theory is a philosophical critique of absolute distance and absolute time that is based upon epistemological assumptions which have largely been overthrown. So there are a variety of ways to interpret the equations of special relativity that give you very different pictures of the world. You can adopt Einstein's picture of the world, where there is no absolute length or absolute time. Or you can adopt the interpretation of H.A. Lorentz, who was Einstein's collaborator and contemporary, who held that there are such things as absolute rest, absolute motion, absolute length, absolute time, but that our measuring instruments are distorted by their motion relative to the framework of absolute rest, so that we cannot measure when we're at absolute rest or in absolute motion. And this leads to a completely different understanding of relativity theory. The equations are the same. In fact, the heart of special relativity is named after Lorentz. They're called the Lorentz equations. But Lorentz, to his day of his death, was never convinced by Einstein's physical interpretation of those equations as purely relativistic and not having absolute motion, time, space, and the rest. So this is a great example of how central philosophy is to our understanding of the way the world is. It's not just based on experimental results and mathematical calculations. There are deep philosophical questions that lie at the very root of this.
When you get into concepts, when you get into conceptual analysis, you're doing philosophy, as Maudlin points out.
Yes, yes, that's right. And this is an example in special relativity theory where Einstein asks questions like, what do we mean by the time of an event? Mm-hmm. And what do we mean by simultaneity and by absolute space? And the whole thing is based upon this conceptual analysis of these classical notions.
Maudlin goes on to say, comprehending quantum theory is an even deeper challenge. What does quantum theory imply about the nature of reality? Scientists do not agree about the answer. They even disagree about whether it's a sensible question.
Quantum theory is the other central pillar of modern physics in its picture of the world. And like relativity theory, the mathematical formalism or the mathematical equations of quantum theory do not carry their interpretation on their face. With respect to special relativity theory, there are a few different interpretations of the mathematical equations, as I said. But with regard to quantum theory, there's a plethora of competing physical interpretations, at least 10 that I can think of. And these differ radically from each other. Some are indeterministic, some are thoroughly deterministic. And they're all mathematically equivalent, and they all make the same empirical prediction so that they cannot be experimentally tested or distinguished. Again, as he says, philosophical conceptions will lie at the very heart of the question of how the world really is.
Yeah, he says that the problems surrounding quantum theory are not mathematical. They stem instead from the unacceptable terminology that appears in presentations of the theory. Physical theories ought to be stated in precise terminology, free of ambiguity and vagueness. And Bill, this just reminds me that any time a skeptic or someone throws quantum mechanics at you, they're probably not being very precise. They're using that as a catch-all phrase.
Yeah, Greg Kokel makes this point. He says that it's sort of a conversation stopper.
Yeah.
You just appeal to quantum physics as this mystical entity, and it explains everything and just halts the conversation. And really, it's being used without much understanding.
Yeah. He says, John Bell provides a list of insufficiently clear concepts. In other words, concepts you can't use when you're discussing quantum theory, and they're words like system, apparatus, environment, microscopic, irreversible, observable, and he lists all these things.
Right, the
imprecise.
normal terms that you would think you could use. But Maudlin points out, how do you determine whether something is a system? Or how do you know if it's large enough to be macroscopic
rather than
as opposed to microscopic? Yeah. Whether an interaction constitutes a measurement or not. These are all controversial issues in the different interpretations of what's going on in quantum mechanics.
Yeah, he says, sharp physical theories cannot be built out of vague notions. So good luck if you want to keep philosophy out of your science.
Yes, it would impede our understanding of the way the world is. What philosophy can do in this case is to help us to understand the alternatives that confront us. It may not be able to decide which alternative is the correct one, but at least it will get us the conceptual clarity of saying there are a variety of ways of understanding quantum mechanics, and here are 10 of them. And this can be important, I think, Kevin, because, for example, in the debate that I have coming up in Germany, I argue for God as the cause of the universe on the basis of the premise that if the universe began to exist, the universe has a cause of its beginning. And the German philosopher I'm debating opposes this. How? By appealing to quantum mechanics. He says in quantum mechanics, these particles arise without any causes, and therefore it's not true that things that come into being must have causes. He just presupposes uncritically an indeterministic interpretation of quantum mechanics, and he is not even aware of the differing interpretations of quantum physics, some of which are thoroughly deterministic. And therefore, this is not a proven counterexample to that premise of the argument.
Maudlin really brings it home here when he says, philosophers strive for conceptual clarity. Their training instills certain habits of thought, sensitivity to ambiguity, precision of expression, attention to theoretical detail that are essential for understanding what a mathematical formalism might suggest about the actual world. Bill, as a layman, I see this all the time. Not only is quantum mechanics used as a conversation stopper, but science is. And I'm saying you don't need philosophy and you don't need religion and all that because you have science. And he's completely blowing this out of the water, as you have done in the past, saying, what do these calculations say about reality? What conceptual analysis can be done based on these numbers?
Yes, it's ironic in Hawking and Mlodinoff's book that you quoted earlier that after they say that philosophy is dead and science has replaced it, the next third of the book is devoted to a debate between realism and anti-realism about science, which is a philosophical question that science itself cannot settle. So it really is important for our understanding of the way the world is that our science be philosophically informed.
Okay. Another quote from Einstein. Einstein says, "How does it happen that a properly endowed natural scientist comes to concern himself with epistemology? Is there no more valuable work in his specialty? I hear many of my colleagues saying, and I sense it from many more, that they feel this way. I cannot share this sentiment."
I found that quotation ironic because I think it was precisely by presupposing a defective verificationist epistemology that Einstein came upon the special theory of relativity and his interpretation of it, which I think is incorrect. I think Lorentz's interpretation is the better interpretation because it's not based upon this verificationism. But I want to make one other point, Kevin. The title of Maudlin's article is Why Physics Needs Philosophy. And I would want to argue that the same benefits of philosophy that he lays out here also answer the question why theology needs philosophy. It's not enough just to do your biblical exegesis and rest there. Good theology requires philosophy for the same reasons: conceptual clarity, logical rigor, discerning various alternatives. The whole article that he wrote here could have been rewritten in such a way as to say that just as the scientist needs philosophy, so the biblical exegete needs philosophy to do good theology.